Hello people, welcome to the channel. Today we're going to be looking at hydrocarbons from crude oil. So let's jump into it.
It was a nightmare.
Activate.
Right, so we're going to talk about hydrocarbons, but before we start, let's do this 5 starter activity, which is answering 5 questions about things that you've done before in the past, okay? So we can press pause on the video, and then you can continue with your marking the answers. Right, so here are your answers. You can correct them if you got them right. If you did get them wrong, you can write the right answer, because it's not enough just to write an X on it saying that you got it wrong. You got to actually know what the right answer was. Okay, so can we correct those and we can start. Right, so carbon compounds, they found in crude oil and are in very high demand, okay, as they can be used for a variety of purposes. Now, crude oil can be described as fossil fuels that can be found underground, in land or sea. Crude oil is made of dead remains of animals and plants that decompose without oxygen over millions of years, and that's something very important that you got to keep in mind, okay? The fact that they've been decomposed without oxygen. When animals or plants die, they decay in the absence of oxygen, and under high pressure, they can turn into crude oil over millions of years. Crude oil is made of hydrocarbon chains of different lengths. So we can see here in the diagram, in the part A, if you have the dead remains of animals and plants, once they die and they get covered with soil or anything else, or for some reason they get covered and they decay in an atmosphere where there is no actual oxygen and there's a bit of pressure, over a few thousand years, what would happen is that it will turn into fossil fuels, into crude oil. In some cases you will have something like this, that you will have impermeable rock at the top, and then the gases will be trapped, creating pockets of gas, those natural methane gas that is actually used in a lot of different countries to use for energy, okay? And you also have oil, and that is actually taken out from the earth by making oil wells. Right, seismic exploration, okay? It is a technique used to detect oil reservoirs on land and in the oceans. This technique uses vibrations and detectors to locate a crude oil deposit. So what you have here is you're going to have a shock wave that will be sent up through the ground, and then that shock wave is reflected by the different layers, and depending on how it is reflected, the detectors will have a bit of a diagram. We create an image about what the soil looks like, what type of layers it has, whether it's limestone, shale, sandstone. It will be able also to detect pockets of gases, and then it's very likely that there is going to be oil there. So that's what they do to detect where the oil would be in certain places. Now, miscible liquids. Crude oil is a miscible liquid. This means that the liquids are mixed with each other and they do not form separate layers when they are allowed to set, such as oil and water layers, or layers in the salad dressing. Okay, so if you ever put oil and water together, you mix it, you will see a mixture of oil droplets in the water. But if you leave it down on the table and you leave it settling for a couple of hours, eventually all the oil will just move to the top and the water will remain on the bottom, and both of them are going to separate. Now, in a miscible liquid, you can't see the different layers because there are no layers. All the components in that mixture are mixed together, and you can't really tell what's in there. So that's what you look at when you're talking about a miscible liquid, okay? Crude oil is a miscible liquid because in crude oil there's a lot of different fuels in there that you can't really see them, and they have to be separated by a method called fractional distillation, okay? In a miscible liquid, all those components will have different boiling points. So as you use fractional distillation, you'll be able to collect the ones with the lowest boiling points first, and then eventually you have the larger hydrocarbon chains, and then you'll be able to separate those by increasing the temperature of the whole fractional distillation, okay? Now, task number 1. In your own words, use the following words to describe crude oil, what crude oil is, and what it's made of, using the following words. So you have those words there. You have to create a couple sentences or a paragraph explaining what crude oil is and what it's made of by using the following words. Okay, make sure you use every single one of those words, and you can press pause on the video right now so you can give you time to answer, and then you will have a model example of what I created in order to use all of those words. You can press pause now. Okay, so this is what I got for you guys. It says crude oil is a mixture of hydrocarbon chains with different lengths. Hydrocarbon chains are made of carbon and hydrogen. When fossils or dead remains of animal and plants decay under pressure and without oxygen, they turn into crude oil over millions of years. Okay, so something like that is very simple, and it will help you in those 6-mark questions. Okay, make sure that you're able to organize your thoughts in a coherent way to be able to answer those 6-mark questions in your exams. Okay, so by now you should be able to describe what crude oil is and what is it made of. So we're going to move on to the next part of the lesson. So alkanes are names with prefixes depending on how many carbon atoms they have, and they all finish in "ane" for alkanes. Okay, so within the crude oil, you got loads of different hydrocarbon chains of different lengths. However, some of them can be alkanes and some of them can be alkenes, and our later point we'll be looking at alkenes, but for now we're going to focus on alkanes. Okay, now meth means 1, eth 2, prop 3, but 4, pent 5, hex 6, hept 7, oct 8, non 9, and dec 10. Okay, those are prefixes that you're gonna have on alkenes. So for instance, methane, it will be meth for 1 carbon, and ane because it's an alkane. So ethane will be eth because it's 2 carbons, ane because it's an alkane. If it was an alkene, it would be methane or propene or ethene or butene. But because we're talking about alkanes, they will all finish in ane. And depending on the amount of carbons that they will have the prefixes that you can see in the screen right now. Okay, so the example here that we have is methane. So it will be meth for 1 carbon, as you can see over here, it's got 1 carbon, and ane because it's an alkane. So methane means it's a hydrocarbon chain with 1 carbon atom on it. Okay, now we have a little bit of a task over here to complete the following sentence using the words provided. Okay, I know you haven't actually done a lot of hydrocarbons so far, or maybe you have, but what I want you to do is I want you to try to find where these actual words are gonna fit in these 2 sentences over here. Okay, in these 3 sentences over here. So you can press pause on the video, and again, once you finish writing your answers, you can check your answers and press play in the video again. So okay, so now that you written down your answers, you can have a look. So the first one says alkanes are a family of saturated hydrocarbons, saturated molecules that only contain single covalent bonds. They have all a general formula of CnH2n+2, and we're gonna get into that in a few slides. Okay, so like we said, alkenes are named with prefixes depending on the number of many carbon atoms they have. For instance, methane has 1 carbon atom, so meth is 1, and ane because it's an alkane. Okay, right, so task number 3. Let's see who is the boss in this classroom. What you're going to do is that for bronze, so a first level, you newly gain knowledge about writing down the name for the first 4 alkanes. Okay, so if you can write the name for the first 4 alkanes, you have your bronze medal. If you can do the first 4 alkane and also draw the display formula, then you're on a silver level. Okay, so display formula is this over here. Let's go back. So this here, this little skeleton kind of thing with a C and the single bond showing with the hydrogens around it, is what we call a display formula. Okay, so if you want to get that silver level, you have to do the first 4, the name for the first 4 alkanes, and you also have to draw the display formula for those first 4 alkanes. Okay, and to reach the gold level, you're gonna use the first 10 alkanes and draw the the 10 display formulas for all of them. Okay, so as always, you can press pause on the video and then we can check your answers in a bit. Right, so here we go. This is your answer. So methane will have 1 carbon and it will have 4 hydrogens. Remember that carbon is in group 4, so carbon can bond to another 4 different things because it can lend one, they can covalently share 1 electron. Okay, so in this case over here, carbon is bonded to 3 hydrogens and the other carbon, so that's 4, and so is this one. In this one here, every single carbon is connected to another 4 things. This one, 1 carbon and 3 hydrogens. This one, 2 carbons and 2 hydrogens, and this one, 1 carbon and 3 hydrogens. Okay, so that's how you go. You got methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. All right, well done. Moving on. Because hydrocarbon chains can be from just a few carbon atoms long or up to a few thousands, it would be quite lengthy process to draw all of them to try and find out how many hydrogens are in that hydrocarbon chain. Okay, so instead we use this formula CN H and then in brackets 2N plus 2. So this means that depending on the number of hydrocarbons, that the number of hydrogens will be the number of hydrocarbons, the number of carbons at the beginning multiplied times 2, and then you add an extra 2, and that will give you the formula for that specific hydrocarbon. Okay, now let's have a look at an example. So for instance, if a hydrocarbon chain has 2 carbons, right, we got our formula over here, and then that N would be 2 because there is 2 carbons. It says hydrocarbon chain that has 2 carbons, so that would be 2 carbons, and to find out the H's would be 2 times N, which is 2 plus 2 equals 6. So this hydrocarbon is ethane, and it has 2 carbon atoms and 6 hydrogen atoms all around it. Okay, now another example over here, if a hydrocarbon chain has 358 carbons, I really don't know the name for that right now, and it will have carbon 358, and to calculate the number of hydrogens, you get that 358, you times it by 2, and you add 2 more, and that means that when you draw this, if you ever get to draw that, you will have 358 carbons with 718 hydrogens attached to it. Okay, so you see why using this formula is very useful, because drawing that will be a real pain. Right, so moving on. Now you have another activity in this task. Use the formula for calculating the number of hydrogen atoms in a chemical formula and chemical formula of alkanes to complete the following exercise. Okay, so you have 10 different combinations. So you have the first one is 9 carbon atoms, so you're going to use the formula to calculate how many hydrogen atoms will be all together, and then you can actually write down the equation, the formula for it. Okay, so as always, you can press pause on the video and check your answers in a minute. Okay, so we have our answers here, so make sure you correct those, and then if you made any mistakes, make sure you actually put those corrections in your book as well, because as always, it's not enough just to write an X when you got them wrong. It's a matter of finding out what the actual answer is as well. Okay, right, so by now you should be able to describe what crude oil is and how it's made, explain what alkanes are, write the name and formula of the first 4 alkanes, and represent the display formula. Okay, right, so that's it for today. Thank you for watching, like and subscribe, and also remember, the knowledge is power. See you next time.